Welcome to InventorCAM Professor on our series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be working on a prismatic part using 3D machining. If we take a look at this part, you'll see that this is a simple prismatic part with straight walls and flat floors that we can actually machine using our 3D modular to machine this part. We'll start with our first operation, and in our first operation we've taken our target and we've used a 14mm end mill. Now in our levels we've gone all the way down to the bottom of the part itself, and in our technology we're using a contour roughing strategy, going down every 3 millimeters, and we'll be leaving also 0.2 millimeters off the wall and off the floor itself. Now we should just note before we continue that the 14mm end mill is actually too big to get into a lot of these areas over here. Okay, let's just take a look now at the simulation, and we'll see that in the simulation, if you use the wire cut simulation, the hose CAD, you'll see it's working around, and in these areas it's obviously not going into. And if I went into a solid verify simulation, you'll see that the tool cuts wherever it can on the stock material as shown here. In my next operation, I'd like to do another rough cut, but this time using a smaller tool. So in this operation, again I've used my geometry as the target, but in my working area I've marked off the box called Cut Only the Rest Material. This will now allow the tool to cut only in the areas that have materials be taken off, taking into account the material that was already taken off in the previous operation shown here. In other words, it's only going to work on what you see in this picture right here. Now, the tool that I will be using will be an 8mm end mill now. Technology, the levels will stay the same, and I'll be going down every 2 millimeters, leaving the same floor offset. If I did my simulation, you'll see now that if I use my wire cut, you'll see that the tool is only working in the areas where it needed to work. And if I did my solid verify simulation, you'll see the exact same thing, working only on those particular areas as shown here. Now, in my next operation, I'll do another rough cut, and this time using even a smaller tool. So again, I'll still have this option of cut only rest material, and now even less material is left over to be cut. And the tool I'll be using will be a 5mm end mill. My technology will stay the same, except for my step down will now be only 1mm. And if I go into my simulation, you'll see that now it's only working on fewer areas than it did before, and we can also see the same thing within our solid verify. It's only working in the areas where it needs to work, including these small corners over here and inside those particular pockets as shown here. Now in my next operation, I'd actually like to start machining and finishing the walls itself, and after that also the floors. So in the next operation, I've chosen again my target, and the tool I'll be using will be a 4mm end mill, and my technology I'll be using the option of constant Z, going down every millimeter on the wall itself with a lead in and a lead out of an arc of 2 millimeters. If I were to do the simulation, you'll see that it's only working on the walls themselves and not on the floors, and cleaning every single one of those areas exactly the way it should have been. It's supposed to be cleaned. Now in my next operation, I want to use the same thing, but this time do work only on the floors. So if I open my operation, and you'll see basically everything in the beginning is the exact same thing. Geometry, the tool, even the same tool. I'll go straight to the technology area, and you'll see we're still using constant Z. But in the constant Z area now, instead of using constant Z wall machining, which we did before, I am now using constant Z flat floor machining. In other words, this is going to work only on the floors themselves. If I were to show you my simulation, you'll see that the tool path is only on the floors, such as this floor over here, and these floors over here as it goes around the part itself. We can also see this simulation in Solid Verify, and you'll see again that the tool will work exactly on the floors themselves and not on the walls. Finishing up the entire part, and we've basically after this machined our entire prismatic part using 3D operations. One of the major advantages is that the fact that I do not have to deal with each one of these pockets individually. It automatically picked up the entire part and did this within a very few operations. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.